When they're given 2x is equal to minus 1 plus I root 3, you can write x is equal to minus 1 plus root 3i by 2. If you remember the values of omega and omega square, it will be an advantage. And if you see, this is nothing but omega. Minus 1 plus root 3i by 2 is omega, minus 1 minus root 3i by 2 is minus omega. If you remember that point, then you get an advantage, and then we are done with the problem, like just in 1-2 steps. So 1 plus omega minus omega square whole power 6 minus 1 minus of omega plus omega square. So whole power 6. So 1 plus omega is minus omega square, because we have the property 1 plus omega square equal to 0, and also omega cube equal to 1. So using that properties, you get minus omega square 1 plus omega as, and here omega plus omega square is minus 1, so my plus 1 minus of minus 1 the whole power 6. So this is minus 2 omega square the whole power 6 minus 2 power 6. So this is minus power even plus only the 2 power 6 into omega power 12 minus 2 power 6. Omega power 3 is 1, so omega power 12 is also 1. So the 2 power 6 minus 2 power 6 equal to 0, and the first option. So these are the useful points. Omega square are roots of x square plus x plus 1 equal to 0. So and also omega equal to minus 1 plus root 3i by 2, and omega square equal to minus 1 minus root 3i by 2. So if you use the quadratic formula, you'll get straight away this. And also you need to understand this: omega lies in the second coordinate, omega square lies in the third coordinate. Like that, if you keep writing the observations, you'll get many observations. See, this kind of problems, we don't need the options. We can directly do the problem and then get the answer in a less number of steps. So what we need to do is we need to convert this into polar form, first of all. So what is converting into polar form means the multiplying and dividing with its magnitude. So the magnitude of this number is under root 1 square plus root 3 square. So the mod, if you call this as some z, so the mod z equal to under root 1 plus 3, which is equal to 2. So if you multiply and then divide with that, okay, it looks like the divided by. So then, so the 2 times of 1 by 2 plus root 3 by 2i, the whole power 8. So the 2 times of what is this? We need to write this as cos theta plus I sin theta. So the cos pi by 6, so sorry, pi by 3 plus I sin pi by 3, the whole power 8. So this 2 power 8 into the cos. Okay, there is a short form for cos theta plus I sin theta. So if you use that, then you can directly see when you're doing the calculation for simplicity, it is better to write short form of cos theta plus I sin theta is 8 pi by 3. So we are almost done with the problem. Like 2 power 8 is the modulus and the amplitude is 8 pi by 3. But we know that from the definition of the amplitude, we have a restriction that, what is that restriction? The amplitude should always lie between minus pi to pi. So 8 pi by 3 is exceeding pi. So there is a need of simplifying it. So how will simplify it? 2 power 8 into 6, nearest multiple of denominator. Basically that is actually 9 pi, but like we need to get the 2 pi multiples. That means 6 pi plus 2 pi by 3. If it is 2 pi, then it's easier. So the 2 power 8 into cis of 2 pi plus 2 pi by 3 becomes cis 2 pi by 3. It is not compulsory that you need to reduce the angle less than pi by 2, because for amplitude you can have between minus pi by 2 to pi by 2. So that's why this itself will becomes amplitude. The answer for the question is 2 power 8, which is 256, comma, what is it, 2 pi by 3, right? So 256, comma, 2 pi by 3 is there in the third option. So this kind of problems, we need options also, because the conjugate of this can be written in many ways. If you directly take the conjugate of it, you get 3 plus 2i by 5 minus 7i. That is also conjugate only. That is also answer. But in which form the answer they're expecting, that you need to know. So because they want the answer in a plus ib form. So let us realize or rationalize the denominator. We use the word rationalizing, but that for the surds it sounds correct. But actually in real, in these complex numbers, we are not rationalizing, we are realizing the denominator. So let
So
us
I
call
found
it.
the option, it's option 4.
Yeah, you got it? Yeah.
Yes,
yeah,
sir, I got
correct.
it.
Yeah, it's correct. Correct. You're right. So just do the calculation, you get the fourth option. In this problem also, one important observation is this equation can be written as minus x the whole square plus of minus x plus 1 equal to 0. So the minus x, its equation in minus x. Minus x is the root of this equation. But you already know that omega and omega squares are the roots of this equation. If you take the minus x as t, so the t square plus t plus 1 equal to 0. For that, omega is the root. So basically the minus x should be equal to omega. In place of minus x, if you write omega, that satisfies this equation. So x is equal to minus omega. And automatically the minus x equal to omega square is also another root. So x is equal to minus omega square. So the two roots for this equation are minus omega and minus omega square. You can take any one of them, that's fine, right? So if you substitute that here, so the x plus 1 by x the whole square plus x square plus 1 by x square the whole square plus and so on plus x power 5 plus 1 by x power 5 the whole square. This is what the equation. So if you simplify this, this is omega plus omega square. 1 by omega is omega square whole square plus omega square plus 1 by omega square is omega. Next, omega cube plus 1 by omega cube. So omega cube is 1, 1 by omega is 1. 1 by omega cube is 1. Next, omega power 4 by 1 by omega power 4. That will be again the same expression. Omega power 4 becomes omega and 1 by omega power 4 becomes 1 by omega. So it will becomes omega plus omega square, the whole square again. And omega power 5 becomes again the same reason. 1 plus omega square equal to 0 and omega cube equal to 1. Using that, what it becomes omega square plus omega the whole square. Basically, this is minus 1 the whole square, and this is minus 1 the whole square, and this is 2 square, and this is again minus 1 the whole square, and this is again the minus 1 the whole square. So 8 is the answer. So if you have doubt in between the steps, you just write the neat steps like we wrote, like we can write omega plus 1 by omega the whole square plus omega square plus 1 by omega square the whole square plus and so on plus omega power 5 plus 1 by omega power 5 the whole power 2, and use these properties. Omega cube can be replaced with 1, and 1 plus omega square equal to 0. So if you use these two properties and do the simplification, you'll reach this step. In middle, how many other steps you want, you can keep writing. Because 1 can be written as omega cube by omega. And here omega square plus 1 can be written as omega cube. And so on. And this one, omega power 5 is omega cube into omega square. And this is also omega cube into omega square. Omega cube is 1. Right? So the last expression and the second expression are same. Last but one and the first expression are same, like that. So this becomes omega plus omega square, the whole square, plus omega square plus omega, the whole square. In fact, except the middle one, remaining 4 expressions are same. So the remaining 4 expressions, each one is minus 1 the whole square, and the middle one is 2 square, and you get that. So to get the real part of it, it's important to convert this into a plus ib form. So the trigonometric formulas are the key for here. 2 cos square theta by 2, 1 plus cos theta formula, and sin theta, 2 sin theta by 2, cos theta by 2. And if you simplify this, I mean, you take the 1 by 2 cos theta by 2 if you take common. Then you get cos theta by 2 plus I sin theta by 2. And if you multiply with the conjugate, cos theta by 2 minus I sin theta by 2. And these two product is 1. And you remain with 1 by 2 into, okay, I'll write more steps for better clarity. Minus I sin theta by 2 by cos theta by 2 into 1 by product of these two, cos square theta by 2. We have formula a plus ib into a minus ib is a square plus b square. A plus ib into a minus ib. Directly you can write a square plus b square. If you use that, then what you get here, you get cos square theta by 2 plus sin square theta by 2, which is 1. We know that it is 1. So this value will be 1 minus I tan theta by 2. So half multiplied inside. So the real part of this, therefore the real part equal to half. So the 1 plus 2i by 1 minus. This is a regular calculation for us. What is that regular? If you, because we get this situation many times, 1 plus I the whole square equal to 2i. 1 minus I the whole square equal to minus 2i. So we can say one step. If you see, you need not force your mind to remember these formulas. Automatically you'll remember, because 4 or 5 times you're already done this a plus b whole square formula. 1 square plus I square plus 2 into 1 into I square is minus 1 and 1 minus 1 get cancelled. If you do that 4 or 5 times in different problems, automatically you'll remember that like a formula. That's what you need to do here. This is minus 2i. So the minus in minus plus 2i. And see this one, magically this becomes 1. And the modulus of that is 1. And then because the 1 lies on this positive x-axis, 1 is 1 comma 0. So the argument of that is 0. So 1 and 0. See how simple it is. See, for purely real or purely imaginary complex numbers, you need not worry about identifying the argument by formulas or anything. Any number given on the positive x-axis, argument is 0. Suppose 1, just now we saw. Suppose some 2 is given, argument of any real number, argument of any positive real number. Suppose some root 5. Suppose argument of root 5 is again 0. any positive number, and argument of any negative number, suppose minus log 2, right? So hope log 2, yeah, base whatever, like yeah, base 10 is a positive number. No, like negative of negative becomes positive. Let us take 50. Yeah, then it will be positive. Minus log 50, so then it will be a negative number. So minus, I just took a logs to understand that it need not to be an integer. Yeah, argument of minus log 50 equal to pi. So argument of any negative number is pi, and suppose 2i. So argument of 2i. So any purely imaginary number with imaginary part of it as a positive number will be pi by 2. Argument will be pi by 2. So the argument of any number on the negative y axis, kind of minus like root 13i. So the minus root 13i, the argument of it is minus pi by 2. So for the points, for the purely real or purely imaginary complex numbers, you need not worry about getting the argument by calculations or formulas or something. Directly, if it is on the positive x-axis, 0, negative x-axis, pi, positive y-axis, pi by 2, negative y-axis, minus pi by 2. That's it. Again, the same logic. When they're told that it's purely imaginary, its real part is equal to 0. Just like z equal to a plus ib is purely real if b equal to 0, and purely imaginary if a equal to 0. So that's concept. And if you, for that, you need to get that in a plus ib form. To get that into a plus ib form, you multiply with the conjugate of the denominator, 3 plus 2i sine theta into 1 plus 2i sine theta, as it is objective. You need to habituate writing the direct steps. We multiply with the numerator. Denominator a plus ib into a minus ib. Just now in the previous problem, we did a square plus b square. 1 plus 2 sine theta, the whole square. And when it is purely imaginary, then its real part should be 0. So for getting the real part, you should not calculate completely. What we need to do is, we get a real part when you multiply the real part with the real part and imaginary part with the imaginary part. Real with imaginary or imaginary with real, you get the imaginary part. So purely imaginary means the real part is 0. So the real part equal to 0. Let us call this as z, then the real part of z should be equal to 0. A real part is 3 ones are 3, the plus 2i into 2i, the 4i square, which is minus 4, into sine square theta, by, for real part and as well as imaginary part, the denominator will be the same, 1 plus 2 square 4 sine square theta equal to 0. So for purely imaginary, real part should be equal to 0. And a fraction is 0 only when the numerator is 0. So the only thing that you need to take care at that time is when the numerator is 0, at the same time denominator is also 0, then it is not valid. Denominator should be non-zero. And we know that denominator can never be 0 because it's 1 plus positive value, non-negative value in fact. So the numerator 0 equal to means 4 sine square theta equal to 3. The sine square sine theta is equal to plus minus root 3 by 2. So yeah, sine theta is equal to plus minus root 3 by 2, because the options are given in terms of n pi. So we can write the equivalent cos theta. See, sometimes to convert into that form, writing the general solution of, okay. We have a general solution formula for the squares. So if you use that, You can write this as sine square theta equal to 3 by 4, which is root 3 by 2 the whole square, which is equal to sine square pi by 3. So that implies theta equal to n pi plus minus pi by 3. N belongs to Z. We have a direct formula, so the third option. So I'll just give the formula for reference. In general solutions, what we have is, if we have sine square theta equal to sine square alpha, cos square theta equal to cos square alpha, tan square theta equal to tan square alpha. Sir, what is the alpha here means? Alpha is different for different equations. For sine square, alpha belongs to the 0 to minus pi by 2 to pi by 2 for sine square. And for cos square, it is 0 to pi. For tan square, it is open interval minus pi by 2 to pi by 2, a well-known principal interval for these three functions. So these three alphas corresponding in the corresponding interval. Then the general solution for this is theta is equal to n pi plus minus alpha, and n belongs to Z. So this is a direct formula. So if you use that, so here sine square theta is equal to sine square pi by 3 we could write, and this is alpha and this is theta. Because the squares are there, in all the three cases you get the same formula. Theta is equal to n pi plus minus pi by 3, and that's how you got this. They are given the omega value, even though they are not given. If they simply write that omega is a complex cube root of unity, still you'll take the same. And yeah, like you use all the properties that well-known properties for this omega. What are they? 1 plus omega square equal to 0, and omega cube equal to 1. So if you use the properties, then see what it becomes. So we took 3 common because 3 is common in the first and the last. And now we use 1 plus omega square as minus omega. 3 times minus omega plus omega the whole power 4. This automatically becomes minus 2 omega the whole power 4. Minus power 4 is plus, and then 2 power 4 is 16. Omega power 4 is omega, and 16 omega third option. See, for this kind of problems, what you need to do is, you see this x and 1 by x, and their sum is cos alpha. Then you need to consider x is equal to, it's not considering, and this will directly imply that x is equal to cos alpha plus I sin alpha. Basically, cos alpha plus I sin alpha will satisfy this equation. Then automatically 1 by x will be cos alpha minus I sin alpha. Sir, how, sir? 1 by x will be 1 by cos alpha plus I sin alpha? Yes, 1 by cos alpha plus I sin alpha. If you rationalize the denominator, actually I call that as realizing the denominator, converting into real numbers. That's okay, but like people used to call that as rationalization. So let us call the rationalization. So if you rationalize the denominator, then the numerator becomes cos alpha minus I sin alpha, denominator becomes 1. Now, automatically, if you add these two, you get this. So the same way, now it is easy to calculate whatever they want. So directly x power n, using De Moivre's theorem, cos alpha plus I sin alpha whole power n will be cos n alpha plus I sin n alpha. And 1 by x power n. So cos alpha minus I sin alpha whole power n will be cos n alpha minus I sin n alpha. And when you add these two, obviously that I sin n alpha will get cancelled, and the 2 times cos n alpha, and that is this. And the formulas corresponding to that we used are De Moivre's theorem. What is the De Moivre's theorem means? Cos theta plus I sin theta, the whole power n, equal to cos n theta plus I sin n theta. This is what the De Moivre's theorem. So when you are adding these two, so cos n alpha plus I sin n alpha plus cos n alpha minus I sin n alpha. I sin n alpha get cancelled. 2 times cos n alpha, that's the fourth option. Its calculation is quite simple, and we just use that two important observations. We can't call them as formulas. 1 plus I the whole power 2 is 2i, and 1 minus I the whole power 2 is minus 2i. Just one step we skip, that's all. Within one step, you'll get that as a formula. If you try to use that, 1 plus I the whole square the whole power n equal to 1 minus I the whole square the whole power n. So this 2i the whole power n and minus 2i the whole power n. These two should be equal means. So the 2 power n, the I power n equal to the minus 1 power n, the 2 power n, the I power n. Whatever the n is, 2 power n will be the same, I power n will be the same. So the 1 should be equal to the minus 1 power n means the n should be even number, and the least even number among the options is 2, and that's the answer. So the least positive integer for which the minus 1 the whole power n equal to 1 is 2 itself. Positive integer starts from 1. For 1, they won't be equal. The next one is 2. For 2, they are equal, and that's the answer. So first of all, what is this locus means? Locus means set of all points satisfying a given condition. A small example to understand the locus. So the locus of z such that mod z equal to 1. That means what is mod z in complex numbers? The distance of the complex number from origin. So the locus of z such that mod z equal to 1 means set of all complex numbers, set of all points on xy plane such that the distance from that point to origin is 1. So if you collect all those points, so this point is at 1 unit distance, this point is at 1 unit distance, this point at 1 unit distance, this point. If you collect all such points which are at 1 unit distance from origin, they form a circle. So the locus of z means a set of all points satisfying this condition. Set of all points satisfying these conditions is a circle. But that circle will have an equation, right? So what is that circle equation means? You replace the z with x plus iy and use the properties of complex numbers and simplify. So mod x plus iy is root x square plus y square. And x square plus y square equal to 1. See, without knowing this diagram and all, simply if you do the simplification, you get it. But to understand the logic behind what is the locus, if you have imagination of this diagram, you'll understand that yes, all the points which satisfy this condition lie on this circle, and I'm finding the equation of that circle, you'll feel that. So that will help us. The same way here, you need to find all the points z which satisfy this condition. The argument of z minus 2 minus 3i equal to pi by 4. So what is z? So you will replace z as x plus iy. So the x plus iy minus 2 minus 3i equal to, of course, the argument. Argument of this is equal to pi by 4. So that means x minus 2 plus I into y minus 2, y minus 3, sorry. And argument of this is pi by 4. So that means argument of this is pi by 4 means geometrically, if you try to understand what is argument of a complex numbers is pi by 4 means. So that if the point is here, then the argument of that is pi by 4. If the point is here, then the argument of that point is pi by 4. Because the line joining origin to that point will make an angle pi by 4 with the positive direction of x-axis. So all the points on this line, y equal to x will have that. So all the points on this line y equal to x will have this locus. All the points on this y equal to x will have this argument pi by 4. Suppose if you take a point here, then the argument won't be pi by 4. That means both y and x should be equal for that point, and also y and x both cannot be negative, both should be positive, right? That's for the condition for this argument. So instead of worrying about argument like this, let us use the formula of argument and then get it. So I am explaining the meaning of this geometrically. Geometrically, argument pi by 4 means that should lie on this y equal to x line. So that means for the points for which the argument is pi by 4, you directly get the x coordinate equal to y coordinate. So if you use that logic, you get the answer for this directly. What is that? X minus 2 equal to y minus 3, and x minus y plus 1 equal to 0. That's directly fourth option. Sir, what if that they are not given pi by 4? What if they're given pi by 3 or pi by 2? That time, isn't it difficult? Yes. That's why we're going to learn an alternate method. What is that alternate method? If you remember, I gave these formulas like the tan inverse, argument formulas. Argument of z equal to the tan inverse mod y by x when z belongs to the Q1, and the tan inverse, the pi minus the tan inverse mod y by x, z belongs to Q2. And I told that only these two formulas you need to remember. The third formula is the negative of the second formula, minus pi plus tan inverse mod y by x. The z belongs to Q2, Q3. And the fourth one is the negative of the first one, minus tan inverse of mod y by x, and z belongs to Q3, Q4. So if you use this formula, even though you don't know this pi by 4 or some other angle is given also, no need to worry. So let us use that formula. So because we don't have clarity about where it lies, no? So where it lies, we don't have clarity. But because the argument is a known number pi by 4, we know that it is belongs to it's a reverse calculation. Argument is given already. So because argument is pi by 4, then you get a clarity that that lies in the first coordinate. So that we'll use the corresponding formula. The tan inverse of mod y by x, y is y minus 3, by x is x minus 2, equal to the argument pi by 4. So basically the y minus 3 by y minus 2 equal to tan pi by 4, which is 1. Sorry, x minus 2. So then you get y minus 3 equal to x minus 2. The same y minus 3 equal to x minus 2, we got it from the observation. We got it from the formula. See, we must have some observations also, because when they're given some flexibility, some simplicity in the values given in the question, we must make use of that and then reduce the calculation, save our time, and get the answer in less time. To get the amplitude, we need to convert this into cos theta plus I sin theta form. So you can convert this in terms of no, actually there is no need of converting. We have a direct formula. The sin pi by 5 as 2 sin pi by 10 and cos pi by 10, and plus I into 1 minus cos pi by 5 is 2 sin square pi by 10. And if you take the 2 sin pi by 10 common, this becomes cos pi by 10 plus I sin pi by 10. So now you can compare this with r cos theta. So z equal to r cos theta, not cos theta plus I sin theta. If the complex number is in this form, so the mod z equal to r and the argument of z equal to theta. So using that logic and formula, so this will be the r and this will be the argument. Argument and amplitude both the same. Argument of whatever the given complex number z equal to pi by 10, and then the option 4 is the correct answer. See, we just did a similar problem. Basically, the 27th problem is similar to this. So this is the advantage. Once we do one problem and then you get a similar problem again, and your comfortability level will increase. So here, from that problem, the understanding is clear that root x should be equal to cos theta plus I sin theta. Automatically, the 1 by root x will be cos theta minus I sin theta. And automatically, when you take the power 6 and using the same de Moivre's theorem, not power 6, power 12 you need to take. If you take the power 12, then you get x power 6 here. and then cos 12 theta using the De Mor's theorem, cos 12 theta plus I sine 12 theta. And here also 1 by x power 6 equal to cos 12 theta minus I sine 12 theta. So then you get x power 6 plus x power minus 6. Good. When you add these two, that I sine 12 theta get cancelled, 2 times of cos 12 theta. So that's first option. Again, that De Mor's theorem that I used from this step to this step is cos theta plus I sine theta, the whole power n, equal to cos n theta plus I sine n theta. Same that we used in 27th problem. So the question asked is 1 by 2 plus I root 3 by 2, the whole power 1 by 4 is the question asked. So we need to write in this cos pi by 3 plus I sine pi by 3 whole power 1 by 4. Basically, the cis short form of it is cis pi by 3, the whole power 1 by 4. So the cis pi by 12, pi by 3 into 1 by 4 is pi by 12. So the answer is the first option. Again, it's based on the De Mor's theorem. When you need to find the higher powers, or like the rational numbers, power 1 by 4, higher roots, I mean to say, higher order roots, I mean to say. So power 1 by 10, 1 by 5 or something like that, or power 20 or something like that, you need to convert this into A plus IB form. So the Z equal to 3 plus I by 2 minus I, rationalize it, 2 plus I by the 2 plus I. So which is equal to 2 3 is 6 minus 1, I into I square minus 1, plus 3I plus 2I plus 5I, by actually A square plus B square, 2 square plus 1 square, 5, 5 by 5, 1 plus I. So Z is equal to 1 plus I. So 1 plus I is basically the root 2 times of 1 by root 2 plus I into 1 by root 2. Basically the root into cis pi by 4, cos pi by 4 plus I sine pi by 4. So the convenient notation to apply this De Mor's theorem. So the Z power 20 equal to root 2 cis pi by 4, the whole power 20. So the root 2 power 20 is 2 power 10, and cis pi by 4 power 20 is cis 20 pi by 4, which is 5 pi. Cis pi 5 pi is cos pi plus pi becomes a pi. Cos pi plus I sine pi, cos pi is minus 1. So the minus 1024 and the first option. So if you think about using the elimination method, for n is, suppose the two roots are there, so you can't start with just one first root, and then you must have the n value at least 2. So the square roots of 1, if you take, so the 1 power 1 by 2, the square roots of that are 1 and minus 1. Square roots of 1 are 1 and minus 1. So, and 1 and minus 1 lies on the positive and negative x-axis. So their arguments are, suppose this is Z1 and this is Z2. So the Z1 line joining Z2, Z1, Z2 won't make pi by 2 angle at origin. So one of the values in the form of 4k plus 2 is not satisfying this condition that the Z1, Z2 subtends a right angle at origin. What is the meaning of Z1, Z2 subtends a right angle? Line joining Z1, Z2. The meaning of the question asks, suppose this is Z1 and this is Z2. So the line joining Z1, Z2 will subtend one angle at the origin. That angle should be pi by 2. That's what the question asks. So for that, what must be the restriction for n? The n should be in the form of 4k, or n should be in the form of 4k plus 3, 4k plus 2, 4k plus 1. So we can use the elimination method. For example, take k is equal to 0, then you get this as 1, 2, 3, 4. 1, 2, 3, 0. So I mean to say the numbers in the form of 4k, 0 is in the form of 4k, but you can't take the 0. And 1 is in the form of 4k plus 1, but we can't take 1 because at least 2 points we need. So we started verifying the 4k plus 2. So the 2 points are Z1 and Z2. The two roots, square roots of unity are 1 and minus 1, but they are not subtending the pi by 2 angle. So this is the wrong option. Next, the cube roots of unity are like 1 omega and omega square. And where they are, if you see the 1 omega and omega square in this unit circle, if you write the omega, basically the omega is cis 2 pi by 3. And omega square, if you want, you can just convert that into polar form and then check. This is cis 4 pi by 3. That means the omega is here. This is what the omega. The inclination of that is 2 pi by 3. And the omega square is here. So the this angle is 4 pi by 3. Technically, you can't write cis 4 pi by 3 because argument cannot be more than pi. But you can write in the process of simplification. This is equivalent to cis minus 2 pi by 3. This minus 2 pi by 3. We should give the argument as minus 2 pi by 3. When you're writing it as argument, you should write as minus 2 pi by 3. And then if you see that angle made by omega and omega square at this point, angle made by omega and omega square, this is not pi by 2, this is 2 pi by 3. So this 4k plus 3 is also eliminated. Next, let us go for the fourth roots of unity, which are 1, minus 1, I and minus I. And if you take them on the unit circle, and you have I here, and minus I here, minus 1 here, and 1 here, and you take Z1, Z2, you can take any two. So actually the question asked is, you should have at least the two complex number Z1, Z2 such that the line joining Z1, Z2 makes a right angle at the origin. And now you can find like more than one pair in this fourth roots of unity case. But actually it is not enough for us to confirm 4k as the correct answer. We are using the elimination method. We can only find the wrong answers with the help of the values. So we need to go for the fifth roots of unity. The fifth roots of unity, no need to worry that like cis 2k pi, this 0 is cis 2k pi whole power 1 by 5, cis 2k pi by 5, basically cis 2 pi by 5, 1 cis 2 pi by 5 and cis 2 pi by whole square and so on, cis 2 pi by 5 whole power 4. These will be the roots. 2 pi by 5 is how much approximately? 2 pi is 360 by 5, the 72 approximately here. So if you have the diagram for that, you have your Z1 here. Of course, your 1 here. Let us call them as 1 alpha, alpha square, alpha cube, and alpha power 4, fifth roots of unity. Your alpha is here, your alpha square is here, and your alpha cube is here, and your alpha power 4 is here. And if you see, you take any 2 points, they won't make a right angle at origin, because the angle between the angle made by line joining any 2 points will be a multiple of 72, a multiple of 2 pi by 5. If you take the angle made by alpha, alpha square at the origin, that will be 2 pi by 5. Angle made by alpha and alpha cube at origin, then that will be 2 times of 2 pi by 5. Like that, you take any 2 points, that will be a multiple of 2 pi by 5 and integral multiple of 2 pi by 5. And pi by 2 can never be an integral multiple of 2 pi by 5. So you can never have a 2 points such that they make pi by 2 angle at the origin. So even the 4k plus 1 is also eliminated. That's why we confirm the 4k as the correct answer. Again, instead of giving the information that omega is a complex cube root of unity and all, directly they're given the value of it. And you need to understand that properties holds here also, that what are the 1 plus omega square equal to 0 and omega cube equal to 1. That properties holds good here also. And along with that, you need to know the properties of the determinants, the two properties. What are they? In determinants, suppose you apply a transformation. Let's suppose A, B, C, P, Q, R, L, M, N. You will learn in detail in 12th grade. But when you're doing objective, sometimes we need to learn 1 or 2 points from the chapters which we are going to do in future. That's okay. So here, if you write R1 goes to R1 plus R2 plus R3, still the determinant remains the same. So R1 is added with R2 and R3 corresponding elements. So A plus P plus L, B plus Q plus M, C plus R plus N, and P, Q, L, R, and L, M, N. These two determinants will be equal. That's the property. How it is and all those we'll learn later. But this is the property that you just need to know. And one more property of determinants is if you have a complete row as zeros, in any row or any column, one complete row or one complete column contains zeros, the value of determinant is 0. So you just need to know these 2 points from the determinants. So you start calculating now 1 plus 1 and omega square and omega square 1, omega square 1 and omega. Now by having that point in your mind that 1 plus omega square is 0, and if I have 1 plus omega square in any place of these elements, I can replace that with 0. So when you have that point in your mind and when you know these 2 properties, you will think about R1 goes to R1 plus R2 plus R3. So still this determinant remains the same. So you get 1 plus omega square, 1 plus omega square, 1 plus omega square, and the remaining elements remains the same. And again, now you'll think about the property that 1 plus omega square is 0. So then you will fill the first row with zeros. So and the second row will remain the same. And again, using the property that one row completely 0, then the answer is 0, and that is second option. So we know that there is a one-to-one correspondence between the set of all complex numbers and set of all points in the organoid plane. So we need to represent this in XY plane and try to eliminate the wrong options. Sometimes eliminating the wrong options is better. If you go for the diagram, and if you see the points, based on that you need to take the scale. You have the negative numbers also XY coordinates, and you have till 9. So let us take each as some 2, 4, 6, 8, and 10. Okay, it's difficult on the y-axis. Okay, 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. 2, 4, 6, 8, and 10. Now if you see that 7, 9, x7, y9, 2, 4, 6, 8, 10. 9 and 7 is here. Then the point, and 3 minus 7, x3 and y minus 7. and then minus 3 comma 3. Right, so if you see this, you can easily understand that it is an isosceles triangle. I mean, it is a right angle triangle. It looks like it is an isosceles right angle triangle, and it also looks like an isosceles triangle. So you better calculate the slope of this line and then this, or instead of that, you just calculate the distances of these points. So this is minus 3 comma 3 and 7 comma 9 and 3 comma minus 7. So just calculate the distances, you'll get it. Yeah, actually we could do the calculation of distance between the 2 points before rolling, because that is simpler. We could see that the square of sum of the squares of these two equal to this, and these two are also equal. Right angled isosceles triangle. Sometimes they will directly ask the formula as the question. See, 1 omega square the cube root of 1, their product is. So basically 1 into omega square is the question asked, which is omega cube, which is equal to 1. So why they will give this kind of questions means some people will confuse in this also, and instead of product, they will calculate the sum and they will pick the 0 as the answer. That's what they will do. So first we need to simplify this. The 2 plus I the whole square. 2 square 4, I square minus 1 plus 2 to the 4I by 3 plus I into 3 minus I by 3 minus I. So basically here 3 plus 4I is there. So this is 3. So if you simplify these 3 3s are 9. Minus 4I square will be plus 4. And minus 3I plus 12I plus 9I by 3 square plus 1 square. So 9 plus 4, 13 by 10 plus 9 by 10I, which is the first option. Just calculation. Oh my god, bad. I calculated and then picked the answer. The conjugate of this they asked. That's why they're given that as the first option. Okay, need to be careful. And the conjugate of it is 13 by 10 plus I times of minus 9 by 10. The second option is the answer. Yeah, need to be very careful. Multiply the denominator with the rationalizing factor. We know the numerator is 2I and the denominator is 2. 1 square plus 1. Sorry. Denominator is 1 square plus 1 square 2. So this is I. So I modulus and amplitude we already discussed that modulus is I is 1 time of cos pi by 2 plus I sin pi by 2. So the modulus is 1 and argument is pi by 2. So the De Moivre's theorem in the short form, we need to know what is that cis theta, the whole power n equal to cis n theta. That is the De Moivre's theorem, and along with that, cis theta 1 into cis theta 2 equal to cis of theta 1 plus theta 2, and this is also we need. And the cis of theta 1 by cis theta 2 equal to cis theta 1 minus theta 2. So if you know these 4 formulas, we are done with this problem. So this is cis of minus theta. Yeah, the one more the property is you need to understand the cis minus theta is nothing but cos theta minus I sin theta. So no need to put the minus in front of cos, because cos of minus theta will be cos theta, sin of minus theta minus comes out. So if you know these this notation and these formulas, then we are done here. So the cis of minus 2 theta minus 8 theta this becomes, and this is a cis of I think I copied it wrongly here. This is also 4 theta only. So the cis of minus 20 theta by this is cis of minus 6 theta. And this is cis of minus 3 theta into minus 9, 27 theta. So this is cis of minus 28 theta in the numerator, and the cis of the 21 theta in the denominator, and the cis of minus 28 minus 21 minus 49 theta, so which is given in the fourth option. Cos 49 theta minus I sin 49 theta.